Welcome to the Day 5 notes for chapters 2 and 3. We're going to look at 2.2 graphs of functions. So we're going to introduce domain today and range a little bit more specifically. So the domain is the set of values of the independent variables. Sometimes we talk about them as input values or x values. The other way I like to think about domain is these are vertical walls when we're talking about graphs. Okay, so vertical walls. Then we're going to talk about the range. So the range is the set of dependent variable, or the set of values of the dependent variable to all the values of the independent variable in the domain. So these are like the y values, the output values. Thinking graphically, I think floor and ceiling when it comes to the range when we're graphing. Okay, so I'll talk more about this in class to help give you a visual. The next video you will have to watch is dealing with this domain and range worksheet. So we'll go to that later on. But first, let's just get into graphing a certain function given a certain domain and see where that takes us. Okay, so this first example here is y is equal to negative 0.4x squared. Well, I see y equals negative 0.4, and what is the value of 0.4 written as a fraction, right? So 4/10, and if we simplify 4/10, that's going to be 2/5. So I'm really graphing y equals negative 2/5 times x squared. Okay, all right, now notice here they give us a domain. The domain is the set of all real numbers. Okay, so the set of all real numbers. That means my x values can be any values I so choose. Okay, any values I so choose. So I want to make sure that in my table I pick some negative values, I pick 0, I pick some positive values. All right, so let's see what we get. So I am going to choose, well, I might start at negative 5. And you might ask, well, why are you starting at negative 5? Well, if I start at negative 5 and I square that for x, negative 5 squared is going to be 25. If I multiply 25 times negative 2/5, all right, I'm going to take that 25, divide by 5, which is 5 times negative 2. I'm going to get negative 10, which is a nice point to plot. Okay, if I started with, let's just say, negative 1, what am I going to get for my y value? Well, negative 1 squared is 1 times negative 2/5. I get negative 2/5. It's not the nicest y value to plot if I want to plot exact values. Okay, so you want to think about the points that you choose in your table. All right, I'm also going to choose 0. All right, because I want to make sure I get a good range or a good set of these real numbers for my x values. So when we plug 0 in for x, we're going to get 0 for y. Okay, if I were to plug positive 1 in for x, we're still going to get negative 2/5. Again, that's not an exact number to plot unless I change my scale over here on my graph. So then I would choose positive 5, because when I square positive 5 and then divide by 5, it's a nice integer. So 5 squared is 25 times negative 2/5. I'm back to negative 10. So I have a good set of numbers here of points to plot. All right. So now let's go ahead and do so. Now, one thing I notice is the grid that was provided, the highest unit it goes up to is 8. There's only 8 tick marks. And I need to get to negative 10. So that means I need to scale my graph a little bit better, all right? Because I can't add points outside of my grid. So I'm going to scale each of these tick marks by 2s. So and I have to make sure that I'm marking that, all right? So that's going to be a 2, and that's going to be a 2. Okay? So we need to make sure we scale it. So now we can go ahead and plot the points. So we had the point 0, 0, so that doesn't change much, right? But then we have the points 5, negative 10, and -5, -10. So if each one is by 2's, that means 5 is going to fall, oh, not right there, but more kind of in the middle there. So 5, -10, so 2, 4, 6, 8, that'll be down here, okay? And then -5, -10, here's where -5 lies. So I'm going to go down to -10, and we can go ahead and connect these. So what you should see is we have a parabola. So what is going to be our range? Okay, so this is where we think floor and ceiling. Okay, can we establish a floor down below? So if you kind of hold this horizontal line here, all right, I'll kind of make it green just so we can kind of see. Okay, if we talk about a floor, can we establish a floor, or will our graph push it down, 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 down? So I notice that these arrows, that means they're going to keep going further and further. So this floor is going to continue to move further down. So there is no floor, okay? The floor is non-existent. But do we have a ceiling above for our y values? So you should notice, hey, I can establish a ceiling. Oops, not right there. Hang on, we can establish a ceiling here. Okay, now we don't need to draw that. That's more for visual purposes for this video. So here's our ceiling, and at what y value does that ceiling, or is that ceiling established? Well, you should see that it's a y value when y equals 0. And what happens is we have every y value accounted for below that ceiling. So the range of this graph is going to be my y values that are less than or equal to 0. Okay, since I have no floor, it goes down, down, down forever. Let's take a look at this next example, or this last example, all right, where we have the function that we're graphing, y equals x minus 2, but this time our domain is non-negative integers. Okay, so I see kind of two parts here. Non-negative, so we talked about what that represents, and then integers. So you have to think about that number set. What is the first non-negative integer? That's going to be the first x value we throw into our table of values. All right, so what is that first non-negative integer? You should remember that it's 0, right? Because non-negative means we want to include 0. All right, so now we have to think about the other non-negative integers. So I would say, okay, well, that gives us 1, 2, and I'll even go to 3. And it would continue on, right? We have lots of non-negative integers. But this right here is the first one, okay? So when we plug 0 in for x, we get -2 for y. When we plug 1 in, we get -1. When we plug 2 in, we get 0. 3 in, we get 1. All right, and so on and so forth. This goes on forever. So since 0, 2 is the first point within this domain, okay, we can go plot that, 0, -2. All right, then we have 1, -1. Then we have 2, 0. Then we have 3, 1, and we would continue on and on and on and on, okay? But remember, 0 is that first non-negative integer for my domain, okay? And since we only want integers, I am not going to connect these points. That would indicate that we are talking about these values in between those integers. But those values are not in our domain. We only want the non-negative integers. So what we're going to do is we're going to continue this trend of just plotting these points, okay? So what we can do is I can attach this kind of dashed line to indicate that this trend of just those integers continues on and on and on forever in this direction. Okay, so this is our starting point. I don't want these integers down here because those are negative integers, all right? So now let's think about, well, what is our range that goes along with these? Okay, so can you identify what the range is? So remember, range deals with the y values, okay? And what's so special? Well, I notice that the smallest y value is -2. But what else are we dealing with? -1, 0, 1, and then we continue on with all those positives. We're not talking about any decimals or fractions in between those guys. So I can say y is greater than or equal to -2, but what does y have to be? Hopefully you recognize y has to be integers. Okay, so y is greater than or equal to -2, and they have to be the integers that are greater than or equal to -2. If you have questions on these, let me know. We'll get more practice in class time.